Hey everybody, uh, welcome to the next video. This one's going to be short, and I hope you believe me, because I'm going to make it very short. Alright, we're talking in our next unit. We have moved on from polynomials, exponents, all that stuff was the first unit that we really kind of covered the whole thing. And I know we talked about systems as well, but now we're going to talk about the next unit, factoring. In this unit, the long story short is we're basically going backwards from what we did in the polynomials unit. So in the polynomials unit, we were distributing things in when we would multiply. We did double distribution and then got an answer, and those answers would look something like this. So what are we going to do this unit? Well, we're going to actually kind of go backwards in this unit. So we're going to start with something that looks like an answer from last unit, and we're going to try and break it down. Factoring basically means break something down into simpler pieces. So the first thing I want to talk about with factoring is if you're given a polynomial that looks something like this, we want to say to ourselves, can I break this down? And the very first thing you want to do with every single problem in this unit, I cannot emphasize that strongly enough, every single problem, you always want to try to factor out. Now, what do I mean by that? I mean, we want to look at each term and see if there's anything common. So if I look at these three terms, 6x squared, 3x, negative 21, are there any variables that are common in all three? No, unfortunately. Are there any numbers that go into all three of these? The answer there is yes. We can factor out, we could divide out a 3 from every piece of this polynomial. Now, when I do that, I would have to make it look like what a problem started as last unit. So if you think about it, what I've done is I've said, okay, this can be divided by 3, this can be divided by 3, and this can be divided by 3. So I'm going to pull out a 3 and then put a parentheses after it, meaning that we have divided out a 3, and if I divided 3 out of 6, 2 would be left over. If I divided 3 out of 3, just 1x would be left over. If I divided 3 out of 21, 7 would be left over, and I kept the corresponding signs. Now this is called factor out, or factoring out. So that's the first thing that you need to know to do. You need to be thinking about that on every single problem. You won't always be able to factor out, but you should always try to. Okay? Now here's a more complicated polynomial. So let's look at this polynomial. First of all, I can tell it's a trinomial because there's 3 terms. And I want to think to myself, okay, you could start by thinking about variables. You could start by thinking about coefficients. And in case you're worried about that word coefficient, that just means the number in front of the variables. So in this case, 8, negative 12, and 20. So I always like to start with the coefficients. Is there anything common that goes into 8, negative 12, and 20? Hopefully you're thinking 4. So we're going to be able to factor out a 4. Now, look at the x. Let's start with x's. Are any x's common in all 3? Well, I see x squared, I see x, and x to the 8th. Is there anything that's common all the way through? Yeah, there's 1x in common. You might think, well, wait, what about x squared? But here there's only 1, so I couldn't divide out more than what we've got. We've only got 1 exponent of x here. So I could factor out a 4 from everything. I could factor out an x from everything. What about the y part? How many y's are common? What's the biggest number of y's we could take out? Here there are 4. Here there are 7. Here there are 2. So that means the most y's that are common are 2, y squared. So I'm going to be able to factor out, hopefully I'll start writing down something here in a second. I can factor out 4xy squared. Now, after we factor something out, we always have to put a parentheses. And now look at what I've got left over. I'll pause it after I write everything down and talk about it. Okay. Now, again, when you factor something out, that's like dividing it out. So if I were to need to put it back in by distributing, I'd have to put a parentheses right here. So when you factor something out, you always need to put a parentheses right after it. Now, if I factor out a 4 from 8, that would leave me with a 2. And if I factored out an x from x squared, that would leave me with 1 left over x, so x to the power of 1, which we don't write the 1. Y to the 4th, if we factor out y squared, that leaves me with another y squared. Moving on to the next term. Factor out 4 from negative 12, you're left with negative 3. Factor out an x from an x that's there, that cancels out all of my x's. I'm just left with negative 3y to the 5th. Because it was y to the 7th, I took 2 of those y's out when I divided out, when I factored out. Last part, divide to 20 by 4, you're left with 5. Divide x to the 8th by x, you're left with x to the 7th. And you divide the y squared by the y squared. All the y squareds are gone. So this would be your final answer. Okay? So that's factoring out. Now, the next thing that could happen, I chose some problems from the book because this gets a little more challenging. Here, we don't just have trinomials, we have polynomials that have 4 terms. And if I look at the top one here, xy plus by plus cx plus bc, is there anything all the way across here that's common in all 4 spots? There is not. We are allowed to do something, though, when there are 4 terms. And this only works when there's 4 terms. So if you see something with 4 terms, that's kind of an indicator that you might be able to do this. So you're allowed to, and I'll show you what I do. It's called factor by grouping. And look what I'm doing here in that top line. I'm grouping the 4 terms into 2 sets of 2. Now, just focus on this first pair. Is there anything common here? Yeah, there's a y. I'll be able to factor out a y, and look what I have left, x plus b. Look here, what's common? A c. What would be left? X plus b. Now, I want to pause it there. Look at what I've done. From the first pair, I took out a y, and I was left with x plus b. From the second pair, a c was common, so I factored it out. And what would be left if we factored out a c? X plus b. Now this is the part that takes a little bit of thinking, but it's kind of cool. Right now, in this red line, I only have 2 terms. I know it looks like I have more. One of the terms is y times the parentheses. This is 1 term. Over here, c times parentheses is our second term. In this first term and in this second term, x plus b is common. What do we do with things that are common? We factor them out. So I can factor out x plus b from this term, and I can factor out x plus b from this term out to the front. What would be left over? Y plus c. Just like that. Now let's do another example. We're going to do number 36. This is probably one of the ones that messes people up more than any other problem. So I've already written down a few things. I grouped because there was nothing in common at the beginning. And I look in this first pair. What's common? A p. And if I factor out a p, what's left? Q plus 1. A lot of people forget that 1 because when you factor out, that's like dividing. And if I divide this p by the p that we factored out, we would just have a 1 left over. So there's just 1 there. Plus, what's common in this pair? Nothing. But you could argue that nothing is like dividing by 1. So you can actually factor out a 1 and be left with the same parentheses, q plus 1. Now looking at the beginning and looking at the end, a q plus 1 is common, so we can factor that out and be left with this p plus 1. All right, one last question. We'll do number 42 at the bottom because there's something big and different about 42. Look at what happened just now when I put in those parentheses. Before I put in the parentheses, this said minus tu altogether. But when I put in that parentheses, it chopped off the minus. And all of a sudden it became a positive tu. We can't do that. We can't just chop off a negative and not expect something to happen. So what you have to think of, there's a few ways of thinking about it, but I like to think by bringing this negative in between the fraction, in between the parentheses, that's like dividing out a negative 1. Because it went from being negative tu to now just inside the parentheses is a positive tu. So it changed signs. So it's like dividing by a negative. So what do I also have to do to this term? I also have to divide by a negative there, which would make it a positive. You have to do that. This is something people forget a lot. Now in the first parentheses, t is common, you're left with t plus 4. Then minus, a u is common, and another t plus 4. They both have t plus 4, so that's going to be common out front, t plus 4. And what would be left over? T minus u. That's the answer. That's the end of the video. I'll see you in class on Tuesday. Thank you. And bring questions so we can talk more about this. See you then.